Hello, and today I'll be reviewing problems from AMC 8 2015, problems 1 through 5. Starting with problem 1, these are pretty easy. How many square yards of carpet are required to cover a rectangular floor that is 12 feet long and 9 feet wide? Notice it says feet, but then we want it in yards. And then they also give us that 3 feet equals a yard. And so we can start off by converting the measurements into yards. 12 feet, in order to change from feet to yards, we would divide by 3, and since there are 3 feet in a yard. That'll be 4. 9 divided by 3 is 3. And then now we have the measurements, and then we just multiply these two together to get 12, which is A. Okay, and now problem 2. Point O is the center of the regular octagon ABCDEFG. H, and X is the midpoint of the side AB. What fraction of the area of the octagon is shaded? Okay, so we look at, since it's half, so there are 8 sides, so half of it would be 16, so that'll be 1/16, and then plus we have 3/8, which equal to something over 16, we multiply by 2, 6 over 16, and then plus this 1/16 right here. Our answer is 7/16, and that is not reducible, so our answer is D. Okay, so now we have that Jack and Jill are going at a swimming pool that is 1 mile from their house. They leave home simultaneously. Jill rides her bicycle to the pool at a constant speed of 10 miles per hour. Jack walks to the pool at a constant speed of 4 miles per hour. How many minutes before Jack does Jill arrive? Okay, so we have that their house is 1 mile from their home. The pool is 1 mile from their home. Let's start with Jill. So Jill rides 10 miles per hour. But compared to it's only 1 mile distance, so we can put that as 1/10. And then since everything is in miles per hour, we want to convert everything to something over 60. And then 1/10 equals 6/60. Same thing for Jack. 1/4 is equal to something over 60. That something is 15. So Jill makes it to the pool in 6 minutes, while Jack makes it in 15 minutes. Taking the positive difference between these two numbers equals 9, which is D. Okay. Problem number 4. The Centerville Middle School chess team consists of 2 boys and 3 girls. A photographer wants to take a picture of the team to appear in a local newspaper. She decides to have them sit in a row with a boy at each end and 3 girls in the middle. How many such arrangements are possible? Okay, so we have our 5 spaces, but we are given that only boys can sit at the end, and only girls can sit in the middle. So this is a very simple form of a combination. So defining how many combinations, we just take how many things there are, 3 girls, factorialize, which would be 3 times 2, which is 6. And then we have the 2 boys, so 2 factorial, which is 2 times 1, which is 2. And then multiplying these two together, 6 times 2, which equals 12. Our answer is E. Now, problem 5. Billy's basketball team scored the following points over the course of the first 11 games of the season, numbers shown in the middle. If his team scores 40 on the 12th game, which of the following statistics will show an increase? Well, first of all, before we do anything, let's put 4 in the sequence. So everything else is lined up in numerical order from least to greatest, and then 4 would go at the very end over here. And so immediately we see that A, the range has changed, because the range is the difference between the largest number, which is 73, and the smallest number, which used to be 42. But now since 40 is the smallest number, it'll be 73 minus 40. And so the change in statistics is in A, the range. Okay, problem 6 in triangle ABC. A equals B, which equals 29, and AC equals 42. What is the area of triangle ABC? So whenever we have two lengths that equal each other, we have a case called an isosceles triangle. Two sides are 29, and the base is 42. And then we're trying to find the area, which is base, which is 42, times the height, which we don't know. But we can split the triangle down the middle to create the height, and then in doing so, we split 42 into 21 and 21. And then now we have a clear objective, which is using the Pythagorean theorem to find the height. And then we do that by 29 squared minus 21 squared, which is 841 minus 441, which is 400. Now taking the square root of 400 equals 20. Now usually we would do base times height divided by 2, but since 42 is already divided into 21 and 21, we can just go ahead and multiply 20 and 21, which gives us B, 420. Okay, problem 7. Each of the two boxes contain 3 chips numbered 1, 2, 3. A chip is drawn randomly from each box, and the numbers on the 2 chips are multiplied. What is the probability that their product is even? Okay, so we have our 2 boxes, and then 3 chips, 1, 2, 3, 1, 2, 3. Okay, so the basis for any probability problem, we always have the number of outcomes on the bottom and then what we want on top. Now, in our case, the number of outcomes is the number of chips in box 1 times the number of chips in box 2, which is 9. Now, if you don't understand how I got 9, I will label this out. So since we're drawing 1 chip from each box and both boxes have numbers 1, 2, and 3, we have for pairing up with 1, let's say we draw 1 from the first box and we can get 2, 3, and 1. And then for number 2, we can also get 1, 2, and 3, and so forth for 3, which is still 1, 2, and 3. And then counting up all those possibilities, it's 9 total possibilities. And then we're finding what the probability is that their product is even. So starting with 1, 1 times 1 is not even, 1 times 2 is. 2, all of them work. And then for 3, only 2 works. Counting up those possibilities, we have 5 total possibilities, 5 over 9, which is E. This is problem 8. The number got cut off. What is the smallest whole number larger than the perimeter of any triangle with a side length of 5 and a side length of 19? So relationships between the side lengths of a triangle, let's name our missing side S. S cannot be larger than 5 plus 19, which is 24. So the largest value S can be is 23. We're trying to find the perimeter, so adding these two together equals 47. But the question is asking for the smallest whole number larger than the perimeter. And so the smallest number larger than the perimeter is 48, which is one more, which is number D, letter D. Okay, problem 9. On her first day of work, Janable sold 1 widget. On day 2, she sold 3 widgets. On day 3, she sold 5 widgets. And on each succeeding day, she sold 2 more widgets than she had sold on the previous day. How many widgets in total had Janable sold after working 20 days? Okay, so if you think about it, on her first day she had 1, on the next she had 3, and then she had 5, and then so on and so forth. And then we can see the pattern is they're all consecutive odd integers. So since she worked 20 days, we can simply take 20 squared, which is 400, and that is D. Okay, so finally we are at our last question for today, problem 10. How many integers between 1,000 and 9,999 have 4 distinct digits? Okay, so we have our 4-digit places, and then we have numbers 0, 1, 2, 3, 4, 5, 6, all the way through 9, which is 10 digits. But obviously we cannot have 0 as the first digit since the smallest boundary is 1,000. And so we have 9 digits. For the next one, we also have 9 digits and not 8, because we can add back the 0 this time, so instead of 8, not including the number that we used is the first digit, we have 9. And then now following, since we used 1 from last time, we only have 8 possibilities, and then since we used from last time, we have 7 possibilities. And then 7 times 8, which is 56, and then 9 times 9, which is 81. And then taking the digits, 1 times 6 is 6, and then the only answer that has 6 as its ones place is B. And that concludes today's video.